Good evening, dear students. I hope you all are happy and doing well. You all are fine. Okay. So last class we discussed about the different types of parser. And from the last class we learned that there are two types of top-down parsers. And one is called as recursive descent parser. And the variant of recursive descent parser is also known as recursive descent parser with backtracking. We have already seen the principles, the working styles of that particular parser. Now, and we have already encountered what are the drawbacks of that recursive descent parser as well as recursive descent parser with backtracking. And to overcome those drawbacks, another kind of parser that has been proposed called as your predictive top-down predictive parser or LL1 parser. We already discussed what are the definitions, what are the principles of LL1 parser or top-down predictive parser. And now we are going into the depth of that with the help of example to understand what exactly that parser does, okay, and how exactly it overcome the backtracking which was associated with the earlier version of the parser. Okay, I am Dr. Sudarshan Behra. I am working as an assistant professor in SR University, Warangal. Okay, since June I associated with this university last June. Okay, and I'm doing well, and I hope you are understanding. If at all you are not any single doubt if you have, you can put it in the comment. I am there to help. Okay, but I do believe that in my class no doubt should be there. Okay, because I 100% I try to reach 100% to my students. Okay, if at all, because no one perfect, if at all anything is there, you can just comment me. I will produce a new video for you with a new example. Okay, for a single comment, is one new video will be produced, so that your doubt will be clear. Okay, very good. This is okay. Whatever the rest of the things that you are going to discuss, that comes under lecture 10. Okay. So let us move ahead. Yeah. As we already discussed, this parser has 4 components. One is the input buffer, one is stack, one is the program, I mean the parser controlling program, and second one is the the next one is the what you say, that is nothing but the parsing table. Okay, what this parser actually does, it has as I said before, but I could not explain that before. Now I am explaining. This parser actually has 3 pointers. One pointer point to the input buffer, because the input string or the target string gets loaded into the input buffer. Okay, this pointer point to the input buffer. Second pointer points to the top of the stack. And third pointer points to the parsing table. Okay, third pointer comes last. Actually, the role of third pointers comes last. So first 2 pointer try to realize. First pointer, it is point to the input buffer. It is scan one input symbol, and it is always input symbols are already terminals. Always terminals. Okay, so it is scan one input symbol which is a terminal, and it checks with, and simultaneously it is scan the stack symbol on the top of the stack. If both the symbols matching, okay, x equals to x, I mean small x equals to small x, then fine. The parser go ahead. It scan the second input symbol simultaneously. It pop up the stack, and once it pop up, the next symbol becomes the top of the stack. It points again the top of the stack. then it performs the same thing. Whenever the input symbol in the input buffer is equal to the or identical to the symbol present in the top of the stack, then no issue. If the input symbol, which is a terminal, is not equal to the stack symbol, I mean top of the stack, then there is an issue. Then there is a problem. But that is not simple. That problem can be realized in different manner. If the input buffer, the symbol present in the input buffer is not equal to the top of the stack, that is okay. But if the top of the stack is a terminal, then the matter is closed. There will be an error associated in the input symbol. If not equal to a terminal, if it is a non-terminal, then that non-terminal need to be expanded in order to see the next terminal. In order to hope the next terminal may be equal to the input symbol. That is the hope. In that way, the parser works. Okay. And how it expand? I said it expand. It expand the non-terminal. This expansion process, to expand the non-terminal, it takes the help of the third pointer, which points to the parsing table, also known as M table. Okay. Through that, it find out the right production, it choose the right production and expand the non-terminal. Okay. So here, more or less, the algorithm of the predictive parser is given. We push dollar and star symbol onto the stack. Dollar indicates the bottom of the stack. If nothing is there on the top of the stack, bottom of the stack is equal to the top of the stack. So that is indicated by dollar. Okay. Read the first input symbol, repeat until the stack becomes empty. Yes. Keep on reading the input symbol and keep on matching the input symbol. Matches found, then keep on reading and pop up the stack until the stack becomes empty. If stack top is equals to input symbol, pop the stack. Just now I said. Okay, and move input pointer to the next input. Okay. Else, if the stack top is a non-terminal, consult the parsing table. Why you need to consult the parsing table? Because you need to find out the right production of that non-terminal. Let us assume that the non-terminal has 2, 3, maybe multiple productions, but you have to find out any one. Okay. So to find out the anyone in the sense what? To find out the correct. To find out the correct one, it uses two functions already I discussed. First and follow. Through that, it predicts them and it stores them in the data structure called as parsing table. And whenever required, it get them. It just picks them. Okay. Replace the non-terminal using the table entry. Table entry in the sense what? Right production, which is already predicted and stored in the table. Okay, that can be replaced with the non-terminal. Else, report the error. If both input and stack contains dollar, accept the string. I mean, in the end of the input buffer is called as EOF, end of the file. That end of the file in the input buffer is marked by dollar, and the bottom of the stack is also marked by dollar. If nothing is there to read in the input buffer, that means what? Input buffer is empty. Everything read is happened to everything. So nothing is there to read and nothing is there to replace. Nothing is there to read means the input buffer is empty. Nothing is there to replace means the top of the stack is also empty. Top of the stack is equals to bottom of the stack. If that is the case, the parser accepts the string and parser halt. Work is completed. Okay. If not, there may be error. If not, there may be error. Okay. So now realize them in the form of example. As you see, the grammar is given here. One grammar. E derived T E dash. T is a non-terminal. E is a non-terminal. E dash is also a non-terminal. E dash derived plus T E dash or epsilon. These are, it has two productions. Then T derived F T dash and T dash derive star FT dash or epsilon. It has two products. Then F derive bracketed E or I. If these are the 1, 2, 3, 4, 5, 6, 7, 8. This grammar has 8 production, taking capital E as the start of the production, considering capital E as the start symbol of the grammar. If that is the case, then it uses two functions. This grammar is not left recursive. This grammar is not left factoring. It is a well-defined grammar. It is a well-structured CFG grammar, context-free grammar. Okay. So for this, it is directly. It need not to worry about the left recursiveness and left factoringness of the grammar. Rather, it find out first two steps are skipped. Now third step, it will find out the first of the grammar. Then it will find out the follow of the grammar. How to find the first and follow of the grammar? That means you have to find out the first of every non-terminal and follow of every non-terminal present in the grammar. First of is what? Which represent the first symbol of the string. That means ID. Because E derive T, T derive F, F derive ID. X is greater than Y is greater than Z. What is the meaning of this? This is transitive rule. That means X is greater than Z. Okay, in the same principle. E derive T, T E dash leave it. Just to focus on the first character. E derive T, T derive F, T dash leave it, T dash leave it. T derive F, F derive bracketed E or ID. Bracket is a terminal and ID is a terminal. That is why the first of E is ID comma bracket. I mean opening bracket. Then E dash derive plus T E dash or epsilon. That means plus. Plus is what? Is it a non-terminal? No. I asked you the question before. Is it a non-terminal? No. It is a terminal. And epsilon is also a terminal. So here E dash has two first symbols. Okay, first is a terminal which appears in the first of the string. Okay, so E dash has two strings. E dash derive plus T E dash or epsilon. So in the plus T E dash, the first symbol appearing as a terminal, that is plus. Then in the epsilon, E dash derive epsilon, epsilon is a null string, that is also a terminal. So here the first of E dash is plus epsilon. Similarly, first of T is derived as calculated as ID, comma open bracket. First of T dash is derived as calculated as what? Star and epsilon. First of F is calculated as ID and open bracket. And follow is the symbol which is immediately appears next to the non-terminal. So follow up is what? What is E? E is the first symbol of the grammar. Okay. After E, what is there? Whenever first symbol is there, the after E, what should be there in the input buffer? Dollar, because dollar is in the end marker. So dollar is there. And then after E, you see the last production. F derive E, bracketed E, open bracket E and close bracket. That means after E, which bracket is coming? Closing bracket. So that is why closing bracket also added as a follow set of capital E. So E derive dollar comma bracketed. Similarly, E dash derive dollar comma bracketed E, bracket, closing bracket, and T derive plus comma dollar comma close bracket. T dash derive plus comma dollar comma close bracket, and finally F derive plus into dollar and close. These are the follow set. So here this much is calculated. Step 3 and step 4 is as per the step 3 and step 4 is concerned. Next, how to design the predictive parsing table. To design the predictive parsing table, already the rule has been told. Already the rule has been discussed. This is the rule. The rule is already discussed that if A derive alpha, try to understand, if A derive alpha is a production and small a is the first of alpha. Then M means parsing table. M of capital A, comma A equals to A derive alpha. So here we have already seen what is the first of E. First of E is ID. What is the production of E? E derive T E dash. So this production E derive T E dash need to be had in all the first symbol of E. So M of E comma ID equals to E derive T E dash. Then E has another first that is called as opening bracket. So M of E comma opening bracket also E derive T E dash. Similarly, all the symbols are filled, and but another case is also there. If that E derive something, if the left hand side deriving an epsilon, then what you have to do? If A derived epsilon is a production, then find out what is the follow of A and add that production in the follow of A. So here you can see follow of E dash is already calculated. You can see in the previous slide, follow of E dash is what? Dollar and epsilon, dollar and closing bracket. So in M of E dash comma dollar, there should be E dash derive epsilon, and the M of E dash comma closing bracket, that should be E dash comma E dash derive epsilon. These two things are there. You see. So E dash comma epsilon is present in E dash closing bracket as well as E dash dollar. And anything which is not reachable, I mean which is not touched, anything that will be called as error entry. Apart from those, all these things entry, whatever we can see, the rest of the entry can be considered as error. At any time, the parser falls into that entry, okay, that will be considered as error. Okay, so in this way, the parsing table has made. Now it is essential to understand. Okay, now first and grammar is given, string is given, first and follow is calculated, and based on first and follow, the parsing table is calculated. Now what is the next role? Next role to implement, realize the stack implementation of the parser. Realize how exactly the parser works. Because the parser is already constructed the parsing table using first and follow. The grammar is given, the sentence is given. How the parsing process is carried out using this top-down predictive parsing. That realization is left. That we have to see. You see, that is called as, this realization is also known as stack implementation of. One question will come to you in your exam. Okay, one grammar will be given, input string will be given. Definitely, you are going to use first and follow method to draw the or to construct the parsing table. After that, it will ask you show the stack implementation of a top-down predictive LL1 parser for this grammar. Here is the stack implementation for this grammar. What is the stack implementation? Because the input string is given ID plus ID employee. So in the stack, the top of the stack is now the bottom of the stack is already indicated by the dollar. Now the top of the stack, in order to see the input string, the top of the stack start working from the start symbol of the grammar. The start symbol is E. E is loaded, and in the input buffer, one thing is loaded, the input symbol. What is that? ID plus ID into ID followed by dollar. Dollar is the end of the buffer. Now this tag, what it is, as I said, it has 3 pointers in fact. But now I am focusing on 2 pointers. First 2 pointer, one pointer will focus on the top of the stack, and the second pointer will focus on the input symbol. Top of the stack is E and the input symbol is ID. Are they equal? If they are equal, then the parser proceed. It will pop up the stack and it will scan the next input symbol. But now the question is, are they equal? Are they equal? No. Capital E is a non-terminal which is not equals to an identifier or a terminal called as ID. So what you have to do? In this case, the parser need to expand the capital E. because terminal cannot be expanded. No, ID cannot be expanded further. So rather the stack symbol can be expanded. What is the how can it expand the stack symbol? Because the it is already predicted and kept in the parsing table. See m of e comma id. What is the action? M of e comma id. The action is already written e derived e dash. You see m of e comma id. You see this one. E is expanded as t e dash. Okay, t e dash already predicted, right? So t e dash, and it can be realized like this. In place of e dash will come first, then t. Now id plus id into id as it is in the parser, as it is in the input buffer. Now e dash is on the top of the stack. Sorry, t is on the top of the stack, and id is in the current input. T is equals to id. Is it correct? No. Then T is a terminal? No. T is a non-terminal. If it is a non-terminal, it has to expand. So now T is expanded as T dash F because there is a production T and ID. The expansion is T is derived as FT dash. FT dash means FT dash means T dash will come first and F will come next. As per the insertion rule is concerned. Now the top of the stack is what? Top of the stack is F, and current input symbol is as it is. Previous input symbol ID. F is equals to ID? No. Then is F is a non-terminal or terminal? If it is a terminal, matter is closed. That is an error. If it is a non-terminal, we need to expand that non-terminal. Is it a non-terminal? Yes. It is a non-terminal, so F can be derived with its production. F has two production. F derived bracketed E and ID, but already correct production is already chosen, selected. That is F derived ID. Now F is derived as ID. So what is there on the stack? E dash, T dash, on the top of the stack is ID, and here in the current input symbol is also ID. So top of the stack is ID, current input symbol is also ID. ID is equals to ID. Now the actual matter came. ID is equals to ID. Now the parser proceed. It is top of the stack and it is scan the next input symbol on the input box. Okay, because ID matches with ID. Okay, so how to realize that? Better to remove ID from the input. So now the top of the stack is T dash because ID is already removed, and here the input buffer from the input buffer input symbol ID is already removed. Now T dash and ID is T dash T dash plus ID into ID. Is T dash is equals to plus? No. Is T dash has a production? Yes. What is the production? Epsilon. Use epsilon. What is there in the top of the stack now? E dash. Is E dash is equals to plus? No. Is E dash has a production? Yes. What is the production? Plus T E dash. So E dash is replaced with E dash T plus. Now plus and plus. Plus is on the top of the stack and plus is on the input. Both of them are matching. So the parser process one step ahead. That means it is pop up the top of the stack and it is proceed to scan the next inputs. Okay. Now what is there? The top of the stack is T because both the symbols are removed now, from one from top of the stack and another from the input buffer. So now the top of the stack indicates T and the input buffer, the current input symbol is indicating ID. Is T equals to ID? No. And is T is a non-terminal or terminal? Is it a terminal? No. So it is a non-terminal. If it is a non-terminal, let us break it with its production. Let us replace it. Now T is replaced with FT dash. Okay. Now the new production that has been arrived in the top of the stack. So that is E dash, FT dash. And this one will continue. Now T dash has a production. Yes. T dash has a production called as epsilon. So epsilon will be incorporated in place of T dash. And finally what you will get? E F. What is the top of the stack? F. Now it is not mentioned, but you have to realize. And F is equals to ID? No. But is F is a non-terminal? Yes. F has a production? Yes. What is the production? F derive ID. So ID is matched with now this ID. ID match. Then the non-terminal, the top of the stack will be removed, and ID will be reading of ID will be skip. Next ID, next terminal symbol has to be read. That is into. Okay. So in that way, the parser will continue, and finally the parser will see there is nothing to read on the top of the stack, and there is nothing to read in the input. That means the top of the stack, which is indicated by dollar, equals to the bottom of the stack. We get nothing to read on the top of the stack. Top is equals to bottom, and nothing to read in the input buffer. That means the end of the file is reached, and that is indicated by dollar. So dollar equal to dollar. Finally, it accepts the string. When this situation encounter, nothing will be there on the input in the input buffer to read, and nothing will be there on the top of it. Top is equals to bottom, and nothing is there in the input buffer means end of the file is rich, dollar is rich. So dollar equals to dollar. That means the string is accepted. Only in this case the string is accepted. Otherwise, it shows the error. It is just plus the error to the programmer or to the user to take corrective action, so that any syntactic mistake will be is there. We can cover that mistake. We can rectify that mistake. This is the way top-down parser, top-down predictive parser, or top-down predictive LL1 parser works. I hope it is clear to each one of you, because I started from root and I explained very well. Even though if you have any doubt, you can pass the comment in the comment section. I'll come with a new example with a new video. Not to worry. Subject is very simple. It is a backbone of computer science and engineering, but it is simple subject. If you show the interest, the subject is nothing for you. You can score 60 out of 60 in the external life. Or if not 60, at least 58 you can score. 59 you can score. That is my guarantee. If you show the interest in this subject. Because this is a applied mathematics kind of subject. Nobody can take even half mark from your end. That is my guarantee. But if you don't focus, then remember one more thing. In those steps, whatever steps we have gone through, single mistakes can lead to the entire output as a erroneous output. Everything will be missed. So be careful. Okay. Next, the same thing is realized in terms of the diagram here. The input buffer has ID. ID indicates A is also an ID. ID plus ID into ID. Finally, dollar is placed, and here is the parsing table, and here is the stack. Okay, initially the top of the stack contains the the start symbol of the grammar, that is E, and E is not equals to A. That is why E gets expanded. Okay, E and ID. What is the corresponding production? E derived T E dash. In that way, E will be replaced on the top of the stack with T dash, T and E dash. Finally, T will be replaced with ID. Sorry, F, and finally F will be replaced with ID. And when ID will match with ID, then the parser proceeds to scan the next input symbol, and simultaneously it pop up the stack, and the next stack top symbol will be appear at the top of the stack, and it will continue. This process will continue. Okay, what I explained there, same thing is grammatically, grammatically presented here. Okay, same parsing table, the parsing action, input buffer. It has in 4 parts. One is input buffer, stack, parsing table, and the parsing function. That means the algorithm. Okay. Same thing is also depicted in the form of flowchart. You can read. Okay, it is not difficult. It is easy to understand. If you don't understand, you can comment in the comment section. And this is something more about the LL1 parser. I mean the predictive top-down predictive parser. Okay. Something more about the top-down predictive parser, where you can understand, apart from the working principle of the parser, you can understand what this parser actually does. Okay. So try to understand what are the additional things that we are going to learn about this parser. These are the additional things. What are the condition of a LL1 parser or LL1 grammar? Yes, the LL1 parser always accept LL1 grammar. What is the meaning of this? That grammar should not be left recursive, it should be left factor, and it should not be ambiguous. Okay. So a grammar is LL1 if it has no left recursion, it is left factored, and it has no multiple entries in the parsing table. That means the grammar should not be ambiguous. These are the primary conditions, the conditions of LL1 grammar as well as LL1 parsing. Okay, what are the advantages? It is simple and efficient. It does not what possesses any backtracking. Okay, and easy to implement. Fast parsing technique, useful for programming languages. Okay, disadvantages are cannot handle left recursive grammar in a proper way. Some grammars, if indirect left recursion will be there. There left recursion is of two types. One is direct, another one is indirect. We'll discuss that one whenever we will go to bottom of parsing. If the left recursion is direct, then it cannot accept. That is final. If it is indirect, then the parser sometimes it may confuse. Okay, so this is one of the drawback, and it is not at all suitable for ambiguous grammar. None of the parser, neither bottom up nor top down parser, none of them is suitable for ambiguous. It is a generalized statement. Then a limited class of grammars accepted. Limited in the sense left factored grammar is accepted. Non-left factoring, non-left recursive is not accepted. Ambiguous is not accepted. Okay, right recursive grammar is accepted. So these are the some grammars, important grammars. This particular parser accepts. What are the applications? It will help us in construction of modern compiler. It will help us to understand whether a syntax or whether a sentence is grammatically sound or not, syntactically sound or not, because it is a kind of syntax analysis. It performs that job to check whether a sentence is grammatically correct. And how it does? Through the help of a grammar. Then it also help us to evaluate the expression, complex expression, simple expression, mathematical expression. Okay, it also help us in programming language processing. How to process a programming language, how to convert high level language into machine code or into intermediate form. So this particular phase called as syntax analysis, it helps the user to do that. Okay. So from here itself, we have more or less understand the working principle of top-down parser, I mean recursive descent parser, and its advanced version called as top-down predictive parser or top-down LL1 predictive parser. So here both the types of parser has been covered. Okay, that is one is recursive descent parser, and its variant also recursive descent parser with backtracking. Then top-down predictive parser or LL1 parser. Why it is called as LL1? Because first L indicates left to right scanning of the input. Second L indicates leftmost derivation, and one indicates following exactly one look ahead symbol at a time. I mean, what will be the next input symbol? What will be the next one input symbol? Okay, it find out that, and based on that it works. Okay, so this is all about your top-down parser. We completed here what is compiler, why it is required, why it is benefited for CSE and allied branch student, and how it can help them, why compiler is a backbone of the programming language or backbone of computer science and engineering. Okay, and what are the different tools used by the what are the different phases available in the compiler, and how compiler works as a phase of programming language, I mean the programming language processing system, or you may say language processing system. What are the different phases of a compiler? And so far we covered the first and second phase. What is the work of lexical analyzer? In depth we covered. What is the work of syntax analyzer? In depth we covered. But syntax analyzer is of two types. One is top-down syntax analyzer, another one is bottom-up syntax analyzer. Ultimately, it's top-down parsing and bottom-up parsing. In that, we cover only top-down parsing. Top-down parser has two variants, recursive descent and LL1 parser. We covered them fully with complete example. I hope there will be no doubt. Okay. In the next video, I will come with bottom-up parser. Okay. But here itself, I want to say something that summer vacation has been started. Okay. So I like to take rest for some time, maybe 15 days or 1 month. Then we'll start what is bottom up parser, and how bottom up parsers are more suitable or efficient than top down parser, and what are the variants of bottom up parser, and how they works differently in order to derive the same string. Okay, and in order to complete the parsing process, or in order to guarantee the syntactical validity of a syntax of a sentence, or in order to reject if the sentence is grammatically ill. Okay, these are the things to be discussed in the next video or in the next class, but with some gap of 15 days to 1 month, because now summer is started. I would like to take some rest. Okay, and I also suggest you take rest. Don't go out of the home in this hot summer. Okay, take care of yourself. Take care of your parents, family, sister, brother. Okay, and be happy, stay happy, and keep liking if you really like these videos, or if you really like my lecture, and also subscribe. Okay, this will be my sincere advice and request to you. And take care. All the best. And happy summer, happy holidays, and have a nice day. Thank you. Bye bye. We'll be meeting with a new video starting from the bottom of us. Okay. Thank you.